Okay. Yeah,
And
go
then
to
just in the lesson
individual
8.
preparation. Then it says lesson 8 in the online textbook. So then click on that.
Mm-hmm.
And then where it says lesson 8 review for exam, go down to like the 4th sentence and it says use the index to review definitions. Click on index right there. Do you see it?
Index.
It's
The
like
fourth.
the fourth line down from the very top.
You are strongly encouraged. Oh, use the index.
Yeah, click on index.
Okay. Wow.
All of the terms, and then if you click on any of the terms, it takes you to that in the lesson.
Wow.
So, I mean, I would think these are some of the terms you're talking about, right?
Yeah. Oh, yeah.
So I thought any of these that we weren't really sure about, we could always,
that's nice.
you can write an awful lot on an 8.5 by 11 piece of paper.
Oh, yeah. You can.
So anyway, yeah, I didn't know if you guys knew about that, but I found that was like, dang, that is like really helpful.
No, that's fabulous. Okay. Well, are we ready to start the quiz? Everyone good? Oh. All right, I'm assuming that's a yes. All right, starting off with question number 2. Which of the following variables is or are categorical? The number of animals in the local zoo, a randomly selected brand of toothpaste at a convenience store, and age in years of randomly selected vehicles in parking lots. Age in years of randomly selected. Okay, so I know it's a randomly selected brand. It's definitely one, but I don't know age in years.
I said randomly selected brand of toothpaste because then if it was the kind of animals in a local zoo, it would be categorical because it's a number, that would be quantitative.
Yeah.
And then the age, which really kind of screws you up, the age and number of years, if it was just the type of different cars, if they were just going on the specific types, it would be categorical. But I put a randomly selected brand of toothpaste.
Okay, that's what I
took the test last night.
You can pick more than one.
So I know that's right. You what?
You got that one right.
Yeah. And I do think it's kind of tricky that they put you would think it would say randomly selected brands of toothpaste. That's what threw me. I thought if it's just one brand of toothpaste, you know what I mean? It's like it kind of trips you up. But I put a randomly selected brand of toothpaste and I got it right. So
okay. I trust you.
But I didn't get the next one right.
All right, well, we'll get it right. Let's see.
One of the things too, I was reading up on this one is if it's a phone number to think about, that's not categorical or quantitative either. That would be categorical, which I hadn't, because I think I messed up with that when we were learning it. So if it's a phone number, it seems like it would be quantitative because it's numbers, but it's not. It's categorical. There, but
Okay, sorry, I missed that. You guys were doing question 3, right? And oh, okay. Thanks. One of the doors got open in my house. My dogs were going crazy. So the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and their mean scores was 112. Which of the following statement is or true? Okay. Oh, okay, okay. So this is the definition between parameters and statistics. I remember this. And you would think that it is, I always think it's backwards. So I think the parameter is always the one that you just did. That's a smaller group, but it's actually backwards. So the statistic would be the mean of the scores of the students that were selected, so it'd be 112, and the parameter is the United States, which is 100. If it would help, we can look over here and we can put down the definitions of statistic or parameter, but a statistic is the estimate of the population parameter obtained from a sample. So the statistic is what you get kind of based off the parameter, I think. Parameter, a true, usually known value describing a population. Yeah. So I always think that the statistic is like the big general thing because like, oh, stats say, or the statistic on that is, but the parameter is the big, generally, usually known, and the statistic is what you get from the parameter. Or it's generalized around the parameter, whatever. I don't know if that helps. Did that help, Sherry? What were you thinking from yesterday?
Well, I totally got it backwards too, because I put 112 as a statistic and I got it wrong. So because it says the mean of their score was 112. So I thought that would be, the mean would be a statistic.
It is. So,
oh,
yeah, 112 is a statistic. Did you put 100 as the parameter?
No.
Yeah.
I put, so it says which of the following statements is or are true.
Yeah.
Oh, so.
You probably only got half of it right. Oh, and you put 100 as the parameter?
So it should have been. No, I didn't even put anything for the parameter. The only thing I put is 112 is a statistic, and I got it, the whole thing wrong. I got no points on it at all. Anybody understand that? I don't get it.
You might have to get the whole question right to be able to get it.
Yeah, it says that's only one point. So if he's not giving out points, you had to get both of them to get the 1 point.
So you're thinking if I had put 100 as a parameter and 112 as a statistic?
Yeah.
Okay.
And I can turn mine in first before you turn anything in, so you can make sure that you get it right.
Okay.
Since you've already taken it.
It's so frustrating because one of the things is so you have to read everything so closely.
Yeah. It is
because
so
I didn't
true.
even get it until just now that it says which of the following statements are true. I didn't even read that before. I never even thought about it being more than one.
Yeah.
Okay.
Okay. Number 4. Rotham City, I want to say Gotham City, has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property tax? Shoot, I always get confused between a systematic sample and a stratified sample. I'm gonna look at that real quick. Okay.
The systematic is the one, that's the easiest for me. It's where it's every like 12th, every 9th,
Oh, yeah.
every whatever. So I get confused between the cluster and the stratified, but this one is stratified.
Stratified sampling, items to be sampled are organized into groups. Okay, yep, it is a stratified sample.
Yeah, because stratified said when the items to be sampled are organized in a group of homogeneous or similar items called strata, then a simple random sample is drawn from each of these strata.
Yep. Nice work.
So the next one, see, I think these are really seem close to me. I don't know if you guys think so, but when designed experiments are conducted in a public school systems, researchers typically choose a particular district and a randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? This one is cluster.
Randomly selected.
What does it say for cluster?
Yeah, if they choose a specific district and then they're choosing specifically 4th grade. Let's see.
Yeah, and then they just randomly select the teachers of 4th grade, and then they students. Because cluster sample says it consists of taking all items in one or more randomly selected clusters.
It should be systematic.
It's systematic?
Because it says researchers select every kth, I hate that they use a K, item in the population beginning at a random starting point. That's kind of what it sounds like, is that they're picking the teacher and then going from there in the district, if that makes sense.
But it doesn't have a kth.
Well, the teacher would be for the 4th grade.
But it's in a systematic one, you have to go through and let's say you pick every 10th. So you'd pick that 10th, you'd pick her like first, and then you do the next 10th teacher, and then the next 10th teacher, and the next 10th teacher.
I feel like there has to be a number with systematic. But that's just what I thought. I could be wrong.
Yeah, I think with systematic, you have to, they call it systematic because you're picking, if they had like, I don't know, all these teachers lined up that were 4th grade teachers, and you decided you were going to take the 5th one of every, anywhere, you could start anywhere in the group. Let's say you could even start in the middle, grab that teacher, and then from then on you would grab every 5th teacher after that. That's what I think systematic means, I think. Because it said that we were supposed to take the test before we met today, and so I took it last night, and the answer is a cluster. A cluster sample consists of taking all items in one or more randomly selected clusters.
Well, I guess that's math for you. They throw in all the extra words just to throw you off.
And that is, I think, one of the hardest things about this class is one word. Because I was looking at it too, because cluster it says, and randomly select teachers. Yeah, because it said a cluster sample consists of taking all items in one or more randomly selected cluster. And systematic isn't random. The only thing random about systematic, I think, from reading this, is where they start. Anywhere and just grab something, but from then on, they pick the same number every time. So what the kth, whatever that means, You could put any number in there, every 5th teacher, every 12th teacher, but it would stay the same. So they grab in the middle, they grab that teacher, and then from then on, they would grab the next 12th teacher, then the next 12th teacher. Am I understanding this right, you guys? I don't know.
No, that sounds right.
Yeah, you got
Okay.
it right.
I printed it because I think these are really confusing. Okay, so let's see. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Would be simple random sample, wouldn't it?
Because it's taken from the whole
yeah.
population.
Yeah. I want them all. I want all the questions to be that easy. Asking for too much. Okay, so 7. Do you want to do that one, Cammie?
Sure. A special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a random sample of 100 people. Which type of sampling scheme was implemented? That would be stratified, right? Because they're pulling it from 2 specific groups.
Yeah, I think so. Because it says that items are to be sampled are organized in groups of similar items.
Gotcha.
So the Democrats are similar and the Republicans are similar.
All right.
Sherry's talking, but we can't hear her.
You're muted, Sherry.
I said, should we wait for Cassie to come back?
I didn't even see her walk out. Yeah, probably.
I didn't either till I just looked at the screen and saw that she wasn't there. We can wait a few minutes for her. Chase, are you talking to your little boy?
Yeah.
I want to see him. How old is he?
He's 8 months.
Yeah,
8 months old.
Aren't they so fun? So much work, so tiring, and so much fun.
Yeah. Good job.
Oh my gosh, how cute. Look at him. He is adorable.
Shh.
What's his name?
His name's Vincent.
He is so cute. Does he have red hair?
Kind of.
Yeah.
A lot up
It's
here
hard
is
to
red.
tell.
But all the hair
Yeah.
that he lost on the back of his head has come back, and it came back very, very blonde.
Blonde, yeah.
So just like my
He
hair.
is darling.
And he can see it too. Why?
Yeah. He's like, what are all these people doing, Dad? You, Vincent. It's all about you. Well, thanks, Chase. I just wanted to see him because I knew he was there. I love babies.
Yeah, every so often I'll probably look off screen because he looks at me every time I talk.
That's all right.
Sorry, guys. My dogs are wreaking havoc on my house, so I had to intervene.
Oh, no worries. We are on, did you get 6, Cassie?
Did you guys agree that 5 was a cluster sample, or did you decide it was?
Yeah. Yep.
Okay. And 6.
6 was a simple random.
Okay, yeah.
And then we just waited for you.
Sorry.
So we haven't done 7. No worries.
Okay.
That's fine.
All right.
Oh, wait, did you do this one, Cammy? I can't remember.
Yeah, we decided it was a stratified sample.
Okay.
Okay. Seven was a stratified random sample. Okay, yep.
Mm-hmm.
Yep. Cool. Okay, now we have to use the software, calculate the mean. Okay. I should have already had this put in. But I didn't.
Yeah, so I just brought up the, I don't know what I did with it, actually.
I got 4.771. I just put it in the quantitative statistics description, like the thing we got before.
That's what I did too.
771, 4.771.
Hold on. And copy. Start in A2. Delete. Delete.
Yeah, because then it shows your mean and your standard deviation.
Okay, and the mean you said was 4.771. That's what you guys got?
Yep.
Sweet. That is so cool. I feel like that way is so much easier than the SPSS way.
When I was starting to take it in the summer, you had to do this by hand. I mean, you could figure it out on a spreadsheet, but you had to know how to put it in there as far as like all the little symbols that you use.
Mm-hmm.
So this, they actually have it set up, which is way easier.
Sweet. Using the software, calculate the standard deviation. And it says it, right? Standard deviation 1.912.
2. Yep.
1.912. Okay. So start by creating a histogram of the amount spent in the crossroad purchase, then mark the following statements true or false. I created, it does it for you. So can I just say
it's
yes?
already done. Yeah.
Yeah, see, we actually had to go in and figure out how to create it from a software.
Yeah, that's how it was in the summer too.
Ugh. Okay. Jessica Mayer and her research team measured the body temperatures of a sample of diving elephant seals. A thermostat, I don't know, was placed at a specific location on each seal to measure its body temperature. The body temperature of seals tends to decrease as they dive. The researchers estimated the typical body temperature of each seal at the time they initiate a dive and called this the representative temperature of the seal. Thermistors were placed in the heptic sinus of force of the seals. The seal's body temperature at the start of the dive was calculated to be this. Complete the following table. Use your work to answer the next 4 questions. Okay, so what is the value of the number that goes in the position marked with an A above in the above table? X minus X bar. So
So we
is
need to find
X
the
bar
mean.
37.91? No, because that's up there. The mean.
So we need to find, for A, the value would be 37.91. So we do 37.91 minus the mean. So we have to find out what the mean is.
Oh, okay.
Plus 37.25 plus 0.98. Okay, so it looks like the mean is 38.075. So A would be 37.91, which is the value, minus the mean. Right? Is that right?
Yes.
Was the answer. So it ends up being negative 0.165. But I did the next one over and over and got the same answer every time. So I'm obviously doing it wrong. So I don't know what the answer is. I don't know how they even, because how I thought that you would do it if you were solving for B is that you'd have to do the deviation from the mean. So you'd have to do the same thing and take 37.25 and then minus the mean again to get the first place where A would be, right?
Yeah, what was the mean again? I'll do it real quick.
38.075.
For that one, you would just take the answer that you got in the column B. So you would find that answer, and then you just square the answer you got, and the value would be what you put in that box there.
That's what I did, and it didn't. Maybe I don't know my
square root. Let's see.
Did you get negative 0.825 as the value minus the mean?
825 equals. Hold on.
Yeah. Negative point. Oh, is it 0.825?
Hold on.
Well, if that's the case, it'd be 0.083 just because we have to round to 3 decimal places. Unless that's just the...
I'm trying to figure out how to do a negative with this real quick.
Yeah, so taking 37.25 and then you subtract the mean, which is 38.075, I got negative 0.825.
Yes.
Okay.
So then wouldn't you just square that?
Yeah, you should be able to. .681.
That, and I got that wrong.
It should be 0.681.
I got negative 0.681.
If you're squaring it, which is timesing it by itself, the negative should disappear, right?
Yeah. Should it?
Multiply two negatives.
That is what I did. Okay, how did I do that? Oh. Negative 0.5 squared equals. Yeah, on my calculator, negative. That's what I just took it off my calculator. I didn't even think about it that I was multiplying two negatives. Yeah, it comes up on my calculator. Squaring negative 8.825 squared is negative 0.681.
Mm-hmm.
Yeah.
Okay, that makes me feel better. At least I am wasn't totally off on how I was doing it.
No, you were right.
Okay.
Are you using a standard
Okay.
calculator? Sherry, what kind of
Yeah.
calculator?
It's a 30X,
Okay. So what you need to do is,
but that may
when
be,
yeah, make sure you put the negative in the parentheses with the number and then square it so that it will know that it's squaring two negative numbers.
oh,
Yeah.
That'll be really tricky later on.
So we got positive 0.681.
Yeah.
Okay, just making sure.
Did it come out?
that did it, Cammie. Thank you.
Good.
I did not know that. Okay. Yeah, that came out now.
Sweet. Okay.
Thank you very much.
No problem.
13. What quantity is equal to the sum of the numbers in the squared deviation column? What?
That would be the variance, wouldn't it?
Hold on. What quantity
I put the variance and I got
is
it wrong.
equal to the sum of the numbers? Okay, I put none of these is correct and I got it right.
Yeah.
Okay.
If it was variance, it would be, yeah.
So, but I don't understand what that means. I just put it because none of it made sense to me.
Well, if you look at the index, that's why I put variance. If you go to index and you look up variance, it says a measure of spread of distribution or the standard deviation squared. So to me, I thought that seemed like that's what it was.
If you go back to the lesson that has this actual chart in it, it will show you like the variance is the sum of column B or column A right after the one with all the values. So the variance is the sum of column A. So the sum of the values that we got when it was the value minus the mean. And that would be the variance. And then you have to, in the next column, you have to do an equation that they put up there for you to get the standard deviation of using the sum of the variance that you got there. I don't know if that made sense coming from my mouth, but let me see if I can find it in the book.
Okay, yeah, because I didn't. If you go to the index and then click on variance, I think it will take us to it. It's lesson 3. Oh yeah, that's exactly it, Cammie. So it's lesson 3 and it shows that little chart.
Yeah.
Oh yeah, that's exactly. Okay.
What is the standard deviation of these temperatures?
Yeah, so it's none of them. You're right.
Okay, let's see this thing.
Keep your fingers out of your mouth. Okay.
You guys, when we take the test, is it going to have like a, will it give us like a chart like that we need to fill in?
Probably.
Yeah.
Okay.
Yeah, probably would be best. Something like
But
that.
obviously it probably doesn't have the formula with it, right?
No, it won't. That's why he's letting us use, so that we can use the formula.
Okay. 14. What is the standard deviation of these temperatures? somebody want to read me the temperatures real quick? Because then I can just put them in the thing.
Okay. So what do you want specifically?
The numbers from, let's see, the representative temperatures, I think.
So let's see. So Badil was 37.91.
Mm-hmm.
Roberta was 37.25. Larry was 38.98. And then Per was 38.16.
Okay, I got a standard deviation of 0.715.
Yep.
I'm not sure if that's going to be the right answer. Is that what you got, Sherry? For did it?
0.71. Yeah, it was
I got
0.715. And I actually didn't figure it out. I just put my quantitative chart up
Same
again, and I just
did that.
Is that what you did?
Yeah, I just did that.
Yeah, I just typed them in, and then it gives it to you.
Oh man, that's what I should do. So what was the number?
0.715.
0.7. Mm-hmm.
715. Okay.
Under certain conditions, the standard deviation can be negative. That's false.
That is false. Yep.
Okay. In the same study, the researchers placed thermistors in 3 seals near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals in their aorta, the largest artery in the body. Finally, they placed thermistors in 4 seals in their hepatic sinus. The results from this study are summarized in the table below. Why are they sticking things in animals? They need to chill out.
Doesn't that sound gross? Ooh.
Yeah, I'm like, I don't want nothing put in my aorta just to see how I'm doing on a regular basis. Which?
Okay, so which?
Yep, go ahead.
Which location resulted in the most consistent temperature measurement from one seal to another? So that would be the smallest standard deviation, the extradural, right?
That's what I got.
Yeah, that was the right one.
Mm-hmm.
All right, I'll do this one. The number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. Use the box plot to answer the question. What's the third quartile?
8.
Mm-hmm. Yep, it's 8.
Should be 8. What percentage of the data lies between 4 and 8 hours? Put this number as a percent, not a decimal, but don't include the percent sign. It's 50% of the data, right?
Yes. Yes.
Did you say 60%? 60, 60?
50.
Oh, 50. There you go. See, that's why I had to clarify. I couldn't hear very well.
No, it's in there. Yeah. It's in the other room. It's on the counter.
All right. We good with 18?
Yep. All right. observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 159 and 252 ppm, and values outside of this range are unusual. We assume the mean minus the 2 equals 1.59 ppm, and the mean plus 2 standard deviations equals 252 ppm. It is reasonable to assume the measured nitrate concentration is normally distributed. Question 19. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. I did good old algebra.
I thought this one was so complicated, and I called my husband in here and we sat, and he said, no, you just do this and this. It was like so easy. You just add, because you're trying. I know. I was like, I was forever on this, and it sounds super complicated. But what we want is the mean between those two numbers, 159, 1.59 and 2.52. So you add those two numbers together and divide it by 2. That's the answer.
206.
It's 2.055.
Yeah.
Because you add 1.59 and then plus 2.52. I was just making it so complicated. Equals 4.11, and then you divide that by 2.
1.59.
So you get 2.055
plus 2.52 equals divided by 2. Yeah, there we go. I don't know why I didn't get it right the first time. Sweet, 2.0.
Yeah, that one. That's one of the things I think is hard is when they get really complicated, then you come to one like that, and I was thinking it was way harder. And then when he pointed that out, I'm like, yeah, that was.
That's what they do. They give you a lot of crap to make you confused.
Do they kind of on the exams,
Yeah.
are they kind of in order of how we've learned things or no?
Most of the time they are in the order we learned them.
Okay. Because that kind of is
Most of the
helpful
time.
instead of, okay. It's helpful that they're not jumping all over.
Yeah, I'm with you. All right, question 20 is estimate the standard deviation. So that's basically the same thing as what you did to find the mean. You just use it to find the deviation.
I actually had to make a chart. I made a little applet thing because I didn't know how else to do it.
I just did. I don't know if you can see that or not. Yeah, I just went and did good old algebra. Like, I solved each one of them so that the equation was solving for the standard deviation. And then I made the two equations equal each other because they both equal the standard deviation. That makes sense. And then I just solved for the standard.
Well, you're awesome. I wasn't that smart.
I just like algebra a lot better than anything else, so that's what my brain goes back.
Thanks. Wait, Sherry, what did you do?
I just made an applet. I don't know if you can see it. And then I put the 2.055 because we knew that was the mean, and we knew that we knew what the numbers were that were, I don't know. Can you see that right there? I don't know if you can see that. Can you see that applet?
Yeah, a little. Okay.
So I put, if you do the applet and then the line underneath, the mean is going to be 2.055 because we figured out what that is. And then we know by, if we take, we could figure out, because we knew what the standard deviation was, we figured that out, was 0.2325. So if we have to, okay, the standard deviation on each side was how do I explain this? I'll just read it out like I have it written here. That might be easier. 2.52 minus 2.055. Because that's, we know what the, if we know what the two standard deviations are from the middle. So if you do the applet, the mean would be 2.055. Then put 2 slash marks to the left that would be standard deviations. Marks to the right. Is that making sense? I can't hear you, Cassie.
Sorry, I got so confused in that.
Okay, if you just draw, this is the only way I could do it. If you draw an applet, and then you know how you draw the line straight down, and you put the mean right there at the bottom. So it'd be, the mean would be 2.055. And because they told us what the numbers are for 2 standard deviations out, to the right of the mean, make a slash for your first standard deviation, and then a slash for your second one, and do the same thing on the left.
Okay.
Did you get that? Okay, so they told us the numbers for the 2 standard deviations, because if we look back at the question, when we very first figured it out, it says 1.59 is 2 standard deviations from the mean. Okay. So on your applet, where you've got the mean at 2.055, go 2 down, and it would be 1.59 would be the first one that they gave us. And then if you take the mean in the middle and go 2 up, the other standard deviation, it says, is 2.52. So now is, what are the middle standard deviations? Okay,
so the one down is 1.59. And the one
up, it'd be 2 down.
2 down and 2 up.
Yeah.
2.52. And then we're trying to find the middle one. Okay.
Right, those ones in the middle. So if you find out what the space is in between the two, so if you take 2.055 and subtract 1.59, then you're going to get what's in the, and then divide it by 2. You see what I'm saying? Because you're going to find out what the difference is.
So it'd be 2.33. Yes. That's the right answer. 0.233.
Yeah.
Yay. You're a genius.
No, that one took me a long time too. And I have a husband that's like helpful with some of this, so that's awesome.
Wow. Holy crap, you just blew my mind.
Yeah, I can't, Cammie doing it with algebra would really be the best way to do it. I just have not done math for so long that for me, to have a visual is really helpful.
That's how my brain works. So I think that was super, super great for me because I don't do math.
If I can see it, it's really great. Cammie, what beautiful place do you live in? It's all sunny.
Yeah, where are you?
Arizona.
Arizona, of course. Yep. You what?
I got kicked out because they were watching Star Wars inside, so I have to find myself a shady place so I can see the screen.
We'll just turn the computer screen around because we want to watch Star Wars too.
Yeah, it'd be way more fun than this.
All right.
That's for sure.
So it was 2.33 that you guys got?
0.233.
Okay, I got the same thing.
Awesome.
Okay, awesome.
Algebra works.
And then the next one you have to figure out the numbers between those two. So now you know what the standard deviation is. You figure out what the first deviation, they want to know what the values are between the standard deviation of 1 to the left and the right of the mean. Does that make sense?
Yeah. They just need the number, is what you're saying?
Mm-hmm. Because they want to know it's between what and what is 68%. So we know that that's the first standard deviation.
Mm-hmm.
So what are those two numbers? So if you subtract the first standard deviation from 2.055, that gives you the first one.
Mm-hmm.
If you add it to 2.055, that gives you the second one.
So 2.0
right of the mean.
Minus 1.59 equals.
No, you would subtract what the standard deviation is.
Duh.
Oh, see, that's a lot
So
easier.
2.5 minus point.
Is it 0.233? Isn't that the deviation?
Minus
yeah.
0.233 equals. So it'd be 1.822, right?
Right. So that would be your left one. And then if you go to your right for standard deviation, you'd add 2.055, and then you'd add it to that, and that will give you the second one.
2.288. Let's see.
Yep.
Yay.
So it's that last one. Yep. 1.823 and 2.288.
Weird genius.
Oh, yeah. No,
so
I'm really not.
I'm sorry to do this to you, but my wife was talking to me and I didn't hear any of that last question. How'd you figure it out?
Okay.
Go for it, Jerry. You're the bomb.
Oh, great. I don't know about that. Okay, so Chase, are you talking about 21?
Yes.
Okay, so if you draw an applet for 20 and you just put the mean at 2.055, and you know from the information they gave us in the beginning that the second standard deviation to the, let's just say to the left of the mean, is 1.59.
Okay.
So we need to find out what that first deviation is. So we take the mean 2.055 and then subtract what the standard deviation is, which is 233.
Yeah.
And that will give us that first standard deviation, which is 1.8225. And then do the same thing. Take the mean, which is 2.055, and add 0.233, the standard deviation. And that gives you the second number, which is 2.2875. So that's number 4.
Okay.
They want to know which they're in between. Does that help at all?
Yeah, that makes sense.
Okay. Okay, 22.
Mm-hmm.
The admissions committees for most Masters of Business Administration programs require the graduate management admission test as part of the applications for new students. It has been shown that the scores on the GMAT are normally distributed with the mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission in the School of Accounting at BYU is 500, but it is rare for students with scores less than 600 to be admitted. No pressure there. What is the probability that a randomly selected student will score above 542? Oh, 542 is the mean, so it's 50%. This is something I just learned yesterday. Is that anytime they ask, it'd be 0.5, because anytime they ask, what's the probability that anything randomly selected will score above or below is going to be 50%. It will
Yep.
always be 50%. So it's 0.5.
Okay, now we get to the hard part, because what is the probability that a randomly selected student will score below 600 on the GMAT?
So now we got to find the G score. Anytime they say percentile or probability, we got to find a Z score. I mean, not a G. I'm renaming things. Oh gosh. Okay, what is the probability that a randomly selected student will score below 600?
Okay.
So
Is it
We need-
we find
600
a Z
minus?
score, which is
Oh,
Is it the mean minus the value, or value minus the mean?
value
What is
minus the mean.
So 600 minus 542.3.
Yep. And then it would be over the standard deviation
120.54.
divided by 120. Yeah.
Okay.
okay, wait, what were the numbers for that again? So it was equals
600, which would be the value, because they're asking which one of them will score below 600.
okay, minus the mean, which is
Which
5,
would be 2.3
2, 3. Okay, and then that's
divided by
over
the standard deviation.
120.
Standard deviation of 120.54.
Perfect.
I got 0.
And that'll give us our Z score.
So I got 0.628. Is that what you guys got?
600 4.2.3 equals divided by 1.
I got 0.684. I got a Z score. What Z score did you get, Cammie?
That was a Z score I got.
Wait, what?
Oh.
How did you guys get that number? I'm so
I got
confused.
0.478.
I got
or
0.478 too.
Yeah, that's
did
what
you-
I got. I rounded. I did 0.479. So that's
Yeah.
what I put in the applet.
So
The Z score?
what?
Point
Did I put in the
478.
wrong like deviation or something? So okay.
Did you do 600 minus 542.3 and then divided by 120.54?
So it's 500 minus
Try that, Cammie.
2.3. Okay. And then that's divided by
Divided by
120.54.
120.54.
Oh, I swear I put that in. I don't know why I got that answer. Okay. Yeah, I got 479.
Well, I don't know. I was online last night with the professor when he did the exam review last night. And that's one of the things he said. He said even in his profession, he said he would recommend every single person that we do every single problem twice.
Yeah.
Because he said if you get it wrong twice, then you do it again. But he said a lot of people just, okay, I got it, and they move on. But I mess up so many times the first time, and then I do it again, I get a totally different. I've gotten different numbers several times in a row. But I could ask them, what is the probability that they will score below? So we shade everything into the left.
Yeah, 0.684.
Right?
Yeah.
Yep. That's it.
That's right.
That's what I got.
Yep. That's right.
Okay.
Next question is, will they score above 600?
Oh, okay.
So just shade the other
So we
area.
just want to shade everything to the right.
0.16.
0.316. Yeah. Yep.
Mm-hmm.
.316, right?
Yeah.
Yeah.
Yep. Yep.
Just taking your advice.
Okay, so 25, find the GMAT score that corresponds to the 10th percentile. So that one we have to find the score, right?
Yeah.
Wait, we have to what?
Yeah, so we have to find the z-score, and then we can find the value.
So I
So
just
I
put
go to the applet.
Wait, what do you put in the applet?
You put
Anytime
10%.
this
So
is just something, yeah, you just put 10% in the top.
What's the
But
most
Anytime there's a
shaded?
percentage, well, we still have to find out what, we have to solve for x, but we can't do it without the z-score.
So what
when we
part
go
should be
in and
shaded?
let's see what, well, it doesn't even matter because we need, all we need is the z-score. So we got the z-score and we know because it's the 10 percentile, it's going to be negative. So we need negative 1.282 z-score.
Negative. Wait, how did you get that?
Okay, so if you go to the applet and then put in, was it 10% or was it 90? No, 10.
So you put
So
point
go
one
to, yep,
in the
0.1,
area.
oh, yep, 0.1.
In the area.
Yep, mm-hmm.
Which shaded?
And then that gives you the z-score. But you don't shade anything because all you're trying to find is the z-score. You already know what the area is, so it doesn't matter what is
so
shaded.
Nothing shaded.
No, it doesn't matter because it's going to leave your z-score. Yeah, it can. You can have anything shaded really because the z-score is going to stay the same. Do you know what I mean?
I got 0.126 as a z-score, so I don't think that that's the same.
Okay, let's see then. 0.10.
Because I have the middle shaded, so I think it does matter because it definitely does change.
Okay, if I shade the right or the left, it gives me the same z-score.
So you want to shade what would be 10% of underneath. So you either want to shade
the left,
the far right side or the far left side, but
Okay.
just one, and that'll give you 10% underneath.
Okay.
To give
Yeah.
you the z-score.
Okay.
Either one, either the right or the left. You want just 10%.
Okay, because I was in the middle and was like, this is not right.
Well, and because we're doing 10%, you really want to do the left z-score because it's a negative and you need it to be a negative.
So
Z-score is
-1.
negative 1.282.
Okay. So what do you do with that then?
And then you have x minus, because we don't know what x is. That's what they're trying to get us to find out. Minus the mean, which is 542.3 over 120.54, which is the standard deviation.
So
do you know what to do from there?
what did you get in what were the numbers for your equation? You got x minus
542.3. So you're still doing, it would be the value, which we don't know what it is, minus the mean over the standard deviation.
And the standard deviation was
120.54.
120.54. Okay.
We got to get everything on the other side of x. So to apply 120.54, if you put it up to the, I don't know if you can see this or not. This is how I do it. Oh, it's right there. I don't know. Can you guys see that?
So the circle
really
part
dark,
right
so-
here is going to be your equation. So you're going to write down here, this is going to be your equation. So that's what you're going to plug your numbers into. So it's going to be the z-score times the standard deviation plus
Hold on.
the
Z times the standard deviation.
and it'll be plus the mean.
Because that's how you're going to get rid of it on that side.
Plus the mean equals X.
Yes. So that's going to be your
Yep.
equation behind the percentile, like the numbers that go with the percentile.
Okay. Wait. What was that equation one more time? Sorry. So it was
It's the z-score times the standard deviation, and that'll be plus the mean,
plus the mean.
and that's going to equal X.
Okay. 5.0. Did you guys get 580?
I got
No?
387, rounded to 388.
Okay, what did I do wrong?
So you want to multiply, make sure you remember it's a negative z-score. So negative
Oh.
1.282. Yeah. Because I did that the first time too, and I couldn't figure out why it was off.
Negative 1.
I have 1.282 times
Okay.
120.54.
All right, hold on, sorry. Negative 1.282
No, go for it. Times
Times.
120.54 plus 542.3. Did I just mess you up? Sorry.
5 what?
42.3.
Equals 38.7.
Yeah.
38.
And then doesn't,
Go team.
so it actually rounds to 388.
Yes, it does. Woohoo. So then we just do the same thing. I think I got okay, so the z-score for this was
A positive z-score this time, so I think it's
Yeah.
what you had the first time.
Yeah.
128.
So it's the same thing. It's just a positive instead of a negative z-score.
So
So you already figured this one out.
282 times the standard deviation, which is 120.54 equals plus the 542.3 equals 696.8. So 697.
Yep.
Yeah.
Right. We're getting there, ladies and Chase.
Yay.
Yeah, no kidding.
Oh, 697.
So 28. Are we in 28?
27.
Yeah.
We're on 27.
Quartile of the distribution. Oh, we're on 27.
Yeah.
So it's 461, right? 461. Yeah, that's right.
What?
What are you talking about?
27 is 461, and then
How did you get that?
Now, wait a minute. Oh, we haven't done that yet. Duh. Okay, we're on 27. Yeah, sorry. Well, find the first quartile of the distribution. So what would the first quartile be? That would be 25%. So you go to the applet again and punch in 0.25. And you know it's going to be
5.
to the left. The z-score just shade the left because it's in the 25 percentile. So the z-score is negative 0.6. Yep. And then you just do the same thing.
You do it again?
Uh-huh.
Oh, okay.
It's going to be the negative z-score.
Yep, it's going to be the negative 0.6.
Negative 0.674 times 120.54 equals plus 542.6 equals
461.
I got 623. What the heck? Why did it do that? Okay. Negative 0.674. No. 74 times 120.54 equals plus 542.3 equals 461.
That's it.
Oh.
And then 28, it's the same exact thing. It says find the third quartile. So we know that the third quartile is 75%. So then we go back to the applet, type in 0.75, and you're going to shade to the right because you know it's above the mean. It's above, whoops. Right?
It automatically shades both for me when I type that in and gives me the same z-score.
Same.
Yeah. Oh, yeah. Same thing. So it'll just be instead of negative now, it'll just like the one before, it's positive 0.674.
Times 120 plus 542.3 623 624.
Yep.
25. 14, 38, 69, 461, 624. Okay. 29.
29, I got wrong. I do not understand
Consider
how to do
a
it.
simple random sample of n equals 15 students taking the GMAT. What is the mean of the distribution of the sample means for all such samples? 15.
It should be the same, right?
It should be the same mean.
29. Yes, it is the same mean.
But 5, 4.
542.3.
Oh. Consider a random sample of, the standard deviation would change, but the mean would be the same. Is that right?
Yeah.
Or what do you, so it would still be 542.3?
Yeah.
Oh, yeah. Make
You
it
say
complicated.
542.3?
Yeah.
Isn't that the mean?
Yeah. Just double checking.
So consider a simple random sample. What is the mean of the distribution of sample mean scores for all such samples? Yeah, I don't know. I didn't know how to do that. I made it way more complicated.
It definitely is 542.3.
Okay.
I know that for sure.
Yeah.
See, that was it. Sometimes I just make it hard.
Well, in the last quiz, that's I missed some of the answers, and then when I went back through it, all of these sample means and distribution of the mean and all that stupid crap, they need new words for these.
Right?
But they were always the same.
The mean
They were always
of
the
the
same.
mean of the mean is this.
Is the mean.
Well, it just, the thing is, you start doing these ones before that are like really complicated, and then you come to a simple one like that, and then I totally overthink it. You should see my paper. I was like these problems all over, and then I was like, yeah, I don't get it. But that wasn't hard. But
when they give you more information, like consider a simple random sample of 15 students.
Yes.
It's like, what am I supposed to do with
because
that number?
Yeah, because that's what I did. I did that whole thing where you square the 15 and you have the standard deviation over the top, and then I divided it by the, Okay. Blew that one. Okay, 30. What is the standard deviation of the distribution of sample mean scores for all such samples? So this would be the one where you do the standard deviation divided by the square of 15.
Yeah.
Right?
Yeah.
I think so.
I gotta.
So
I got 31.123.
What?
What was the standard deviation?
Yeah,
again?
that's what I got.
divided by what?
The square of 15.
Square of n,
The square
right?
root of
And this is for the
Dang
standard
it.
deviation.
of sample means. So the standard, is that still the same standard deviation? So is it 120.54?
Yeah.
No,
Yep.
the standard
it'd be
deviation will be different for sample mean scores.
20.54 divided by the square root. 15 was the size of your sample.
Okay. So
Out of 3 decimal places. So I got 31.123.
Yeah. That's what I got.
That's what I got.
Hold on. Sorry. 1 second. So 120.54 divided by 7, 2, 9. You guys got 31.123.
Yeah.
Yes.
Yep. And that's right.
31. Uh-oh. 1, 2, 3. Yes, that is right. Okay, what is the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600?
So we got to get the z-score for that one too, because it says probability.
I got
will be greater
1.854.
How did you get that?
What'd you get?
1.854.
How did you get
Yeah,
that?
that's the z-score. That's what I got too, Chase. That's the z-score. How we got it was taking 600, because we know the number will be greater than 600. So 600 minus 542.3. So minus the mean over, we're going to do the same thing we did for the last one. 120.54, which is the standard deviation divided by 15 squared.
15.
Or square root
If you
of
do it in a
15.
calculator, the plot.
Wait, hold on. So it was, so you have, so X, you have 600
Yeah.
minus
the mean, which is 542.3.
542.3 over,
And then over the standard deviation, which is 120.54,
20.
divided by the square root of 15. So you got to do that first before you can finish the top.
So
Yeah, and if you do it in a calculator, the parentheses will
Hold on.
help a lot.
You guys, that whole parenthesis thing is like super helpful. I had no clue.
15.
I haven't done math for a long time.
So
Chase, how did you
I
put
learned
the
that one in my
parentheses?
last math class.
When you put it in
Well,
your calculator, how did you put this in there?
Well, I have a smartphone that has a calculator on it.
Yeah,
and
so what'd you
when
do?
I flip it sideways, see, it's actually even in the regular calculator. But I do the parenthesis for the top equation, so 600 minus 542.3, right parent.
Okay, wait a sec. I'm going to try this. Okay. You do that, yeah.
And then put a
Right.
left parent, 5.4.
Left parenthesis.
So, sorry, what?
Oh, no, I was just listening. So you do 600 minus 542.3,
Yeah,
and
all that
then
in
divided
parentheses.
by parenthesis.
Yeah, 120.54 divided by the square root of 15.
120.54
put
divided
in
by
a right parent on that
square
side.
root of 15, and then close with the parenthesis.
Yes. So that way the calculator will solve what's in the parentheses first and then divide them together.
And did you guys get 1.853?
Yes,
That's
I
what-
got 1.854. Yeah, I
Yeah.
rounded.
If you round up.
Yeah, and then take it to the applet
Greater
and
than
put it in there
Point-
for a z-score.
0.0312. Is it 3 decimal places?
1.854.
Yeah, so it's 0.
Yeah.
And what are we
And it's going to
highlighting?
be above, we're only going to shade above the line because they want, the
Above
question
600.
was, what is the probability that it will be greater than 600? So the only thing we're going to shade is to the right of the
0.032.
0.0319.
It's 3 decimals, so 0.032. Ooh. 0.032.
Okay, I'm submitting this.
So I have a question.
Yeah.
On the last exam, I had a question exactly like this,
Mhm.
but the z-score I got kept having that E, and so I kind of just put an answer in and I got it wrong. What do you do when you get that?
I have no idea.
Are you talking error or that E thing like it's at the, where it's to the what power? Are you talking about that?
I think so, because it was way too big of a number. It was the last question on the last quiz.
Yeah.
So you might have done.
Yeah, because I got that one.
I got it wrong both times.
Yeah, so you probably did what I did, and you squared the new standard deviation by the sample number. Since we already did that math, we don't have to square the new standard deviation. So since we got the 31.123, that's all we have to divide it by. We don't have to do 31.123 divided by the sample number, or the square root of the sample number. Because that's what I did to get that ridiculously big number, and that was wrong. But if it does show up, even if you think you did the math right, then just go ahead and put the answer in as 0. Because that should be your answer. It'll be really close to 0.
Huh.
By the way, guys,
I have to remember that.
we got 100%.
Oh, awesome.
Nice. I typed in the right answers.
So,
Great.
go team.
Well, good luck, everyone. It's stressful.
Yeah, good luck, for real.
We get this.
We just have to get through it, guys. We don't have to ace it. We just have to do okay on
So
it.
freaking scared. Guys, last time I took this test, I got a 68 on it.
I have to ace it because I
That's
don't
not the
want to take
worst.
statistics ever again.
Yeah, that's what I told my husband. He goes, you just have to get through it. And I'm like, no, I have to do really well so that if I don't do well on another one, that will carry me through.
Oh, yeah, they just get
Yeah.
harder and harder. They get harder and harder.
Especially since our grade is
Yeah.
60% from the exams.
I know, it drives me
Yeah,
bonkers.
exactly.
We put in so much work and effort for like these group quizzes, you know, and they don't count for anything.
I know, it's
Yeah.
pretty annoying.
It drives me crazy.
Yeah,
But
it is.
At
But you
least
guys, I
this
think we're
professor's pretty
getting
good at
it.
letting us notes.
Yeah.
yeah, we're
Did you
doing
guys
good.
read the thing about you could have one note and then he said, I don't care if you use 2 sheets. Did you guys read that in the?
Yeah,
He
in
said
his
you
little
can use
story.
two
Yeah.
sheet of notes if you want it, and then he went through the whole thing about, you know, preparing for a hurricane. I thought that was funny. I don't know what to put on my sheets. That's the only thing. I don't know I don't know which terms and.
I just went in and put in all the things that we just used on this practice test.
Mm-hmm.
And then I'll
Yeah.
probably go through and put some more of the
Terms.
terms. Yeah.
Yeah. That index
I
thing
think
for
the
terms
equations
is
is
pretty
definitely
good.
a big thing.
Yeah,
I
the
just-
equations of the terms.
Like the summaries they have at the end of the lesson, I just copied all that and then put all the didn't have in those summaries on paper.
Yep.
Okay, that sounds awesome. I think the hardest thing for me is I know how to do a lot of the work. I don't always know what they're asking for.
Exactly. That's the hard part. Is you
Yeah.
just have to figure
Yeah.
out what they want.
Yeah.
Mm-hmm. Exactly. And I think we should be able to take this as a group.
Right?
At least one of us might get it. That'd be
Yeah.
awesome.
That's a
Feel like-
3-hour
All right.
exam.
Well, I guess I'll see. Yeah, I know.
Well, you guys-
We can do it though.
Hey guys, before we go, is it okay if we meet like an hour or 2 earlier on Thursday? Does that work
Yeah,
with
I
all
can do whatever.
Yeah. What time do you want to meet?
It would be 8 Mountain Time. So that would be 2 hours before
8
we.
Mountain.
8. Man, that means I have to wake up at 7:50.
Hey, you
Just-
can't
I'm always awake
complain. That
before
means
then
I have
anyway.
to be on at 7 because I'm in the Seattle area, so
Oh,
I got to be on
yeah.
at 7. But yeah, I can totally do
That's
that
just fine.
if that works.
Okay.
I'm just giving you a hard time.
Because my family's going
That was
out of
like my
town.
Okay,
and
so
I'm
be-
behind. Yeah.
Okay, yeah. So it will be 8 o'clock Mountain Time on Thursday.
Yeah.
Cool.
Okay.
Awesome. Thank you guys.
Okay.
Sweet.
Thank
Go
you, you
team.
guys. I really appreciate. I feel like we have a good group. I don't know if you guys noticed on the question and answer, somebody said that they watch the videos from everybody else's group
Yeah.
because their group is not good. So
Yeah.
I'm really
We had
grateful.
to-
I feel like we have a good group. So
We had to do that last time, like several times, where we would go and watch somebody else's while we were doing ours because we were that bad. So,
well, I think we're all trying, and I appreciate you guys because I need the help. So thanks.
I think we do a really good job of understanding for each other and then teaching each other what we don't understand. So, because today
I
I
think it's
was,
working really well.
I got super pumped because I understood several things that I've never understood before. So,
Awesome. Yeah, I feel that way too. I'm like, I don't know how to do this. Then when you guys tell me and I write it down, I'm like, that one that was a negative, I did that probably 50 times. I'm like, what? And then when you guys said use the parentheses, I'm like, what? I didn't know that. So that's awesome. Now I know about the parentheses, which is really
Parentheses
great.
are your best friend.
yeah.
Yeah. Well, I'm going to practice when I hang up just using them because I've never done it that way. So it takes me a lot longer to work it out too. Problem in it once. I like do it in stages. So, all right. Well, see you guys on Thursday. Good luck.
Good luck.
Awesome.
Okay. See you.